All right, let's go ahead and get started. So it seems like in a computing class there's always even more logistics than usual at the start of the term. Let's see. So any of you who are not statistics folks and don't have an SCF sheet for an account should get one. They're on the back table. Those of you who already got them last week and filled them out and logged in for the first time, you can sign them and then get them back to me within the next couple classes. Let's see, so I'd asked everybody to do the class survey. It looks like most of you have done that. It was officially due yesterday. It is part of the first problem set, so you should do it. So go ahead and make sure if you haven't, for those 10 or so of you who haven't done that, please do that by tomorrow or so. And then as I've mentioned before, I'm expecting you to be up and running to some degree with R at the level of the boot camp and the materials that I've posted for the boot camp, sort of roughly the first 7 or 8 modules from the boot camp. So if you don't feel that comfortable with R at that level, you should be starting to do some self-study now, because we're going to launch into R mid to late next week. So this you have about a week to start to get up to speed before I start catching up and surpassing you in the class materials. So go ahead and get started in doing that. We're here to provide help. You can post questions to the website. The first section for class that Tessa will hold will be next Monday, and that will basically be helping folks out with R, answering questions on R. So I'll give you some more details of that in the coming couple days. But starting to do some self-study in advance of that, so you have questions to ask there would be a good idea. What else in terms of logistics? I was just going to mention a little bit about what I did learn from the class survey so far, just to give you guys a sense of who the rest of you are. So there's obviously a big chunk of statistics folks. The other big, relatively large groups represented there are sort of 5 or 10 folks from various engineering disciplines in the class, and then there are maybe 5 or 8 folks from some combination of economics, the Haas School, and political science, and then a smattering of folks from various professional schools and other departments. So those are your colleagues here in the class. In terms of the wait list, I think we're starting to clear off the wait list as things sort of shake down during the first week of class. I just let a whole bunch of people in off the wait list. So right now, my understanding when I looked this morning, which probably reflects something as of yesterday night or something, is that there were still 2 graduate students on the wait list. You guys are reasonably likely to get into the class. I can't guarantee anything. There are 2 people I talked to last class about being concurrent enrollment students. That's still undecided. I think there's a decent chance you'll get in. Although the 2 of you guys, if you're here, it looks like you didn't formally sign up, so I don't have any official record that you're wanting to be in the class. And then there are a couple undergrads who are on the wait list. You guys have lower priority than the graduate students. And if you're one of those 2 people, you should chat with me at some point in the next couple days. We can talk about your background. Okay, I think that's most of the logistics. Any questions, either logistics-wise or questions from any of the material from last time, or anything that came up as you were trying to get up and running in some of the basics of Unix over the last few days? Yeah, sorry.
The only question I have is I noticed you mentioned Sshfs. And I did that. I wasn't sure what the advantage of doing that over SCP is.
Yeah, so Sshfs is one of the various mechanisms. Others are things like Samba for basically having a directory on a remote machine look like it's a local directory on your machine. Yeah. So instead of having to sort of manually copy files back and forth and pay attention to what version is on this machine and what version is in that machine, you can basically just work with the file in a directory that looks like it's on your machine, but it's actually being mirrored. It's actually being copied and pasted, copied it back and forth behind the scenes. So it basically just removes a level of level.
Yeah, I was just wondering if I was trying to put it locally, if there's any difference in efficiency.
Well, you can just do it if you have Sshfs or Samba or something set up. You can basically just do a CP from the remote directory that looks like it's a local directory into a local directory that's actually a local directory without going through the SCP business. Other questions? Okay. So let's pick up where we left off with some of the basics of Unix. We're going to blast through the rest of the unit, the quote-unquote Unix unit, in probably just a few minutes, and then we'll get more into Bash shell specific stuff, which also is of course Unix, but a bit more detailed. So just a quick note that I did just before, as people were filing in here on this machine, I did a git pull. So I had updated materials from my desktop last night and this morning on all the various materials for class. And so I just updated all that onto my laptop so I could present the updated version by just doing git pull. And you can see what it did was it downloaded a whole bunch of new files and files that I've modified in the last few days since I last used this laptop with this local repository. So we'll see a lot more of that in terms of the details of working with version control, of working with Git at the end of the Bash unit, at the end of Unit 2. And I've been adding materials on that in the last couple days. Okay, so we sort of left off last time talking about file transference. Everybody should have, if you weren't familiar with that already, you should have gotten a chance to try and practice that. If you still haven't gotten to be able to do that, make sure you're able to work with files, copy files around, transfer files between machines. So that's the syntax I have here. So the next thing I just want to talk about a little bit is the fact that Unix has basically file permissions. So different people have access to different files depending on how these permissions are set. And files also have different modes of operation. So they might be files that you can only read but you can't write to, or they might be files that you can read and write to, and they might be considered to be executable files or not, depending on whether they're commands or programs, or whether if they're just text files, they may not be executable in any manner. So if we do ls minus l, we've seen this last time. Is that big enough in the back? Any complaints? No? Okay. So this is in my directory having the materials for class. These are the various subdirectories with the various materials in them. And what you see over here is basically information about what kind of files they are and what the permissions are. So this says I'm the owner of the file. I'm in a group called staff on the SCF. This first thing says whether or not it's a directory. This is just a file, for example, this new test.html. And these letters where it says R is whether or not it's readable. And the W is whether or not it's writable. There's possibly a W in this column as well and in this column here. And the X column here, here, and here is whether or not it's an executable file, basically a command or a program. And the reason each of these is in groups of 3, so this first 3 is the possibility of R, W, and X all being set or not set, R, W, and X set or not set, R, W, and X set or not set, the minus means if not set, this is whether they're considered readable, writable, and executable by different people. So the first 3 here, after the D column, is whether or not it's readable, writable, executable by me, the user. This is whether it's readable, writable, executable by the people in my group, if there are multiple people in the group set up on the system. And this is whether it's readable, writable, executable by anybody on the system. So in principle, if this were on the SCF and this said RWX, it would mean that any of you could get to that, could use that file, could read that file, write that file, and execute that file, even if it's in one of my directories. Some of that's going to depend on whether the higher level directories are accessible to you, to whether or not you can drill all the way down. But that's the idea, is that we have control over who has access to what files, and we have control over whether people can read them, write them, and execute them. Okay, so let's actually go to lectures, which has the various class material. And now if we do ls minus l, you can see, oops, what just happened? Oh, I did ls, I meant to do cd to lectures. Okay, so now we can see these are basically all files. It looks like for the most part they're just readable and writable and not executable. And for the other people in my group and the other people in general, if they had access to this machine, which in general there aren't a lot of users on this particular laptop, they're not writable to people other than to myself. If we wanted to change the permissions, we can use a utility command called changed. And I can do things like, if I wanted to make these files writable for everyone, I can say user, group, and other, plus add write permissions for some file. Let's say the unit1-unix.sh. So this is going to add write permissions for everybody to that particular file. And now if I do ls minus l again, you can see for this file here, which I just referenced, it now has a W next to it for all 3 sets of types of users. I could have said make that readable and writable for all of those users, and I could also have taken away read-write permissions for all of those users with the minus. So basically the syntax is which of the types of people you want to change permissions for, add or subtract permissions, and what kind of permissions you want to grant or deny access. So I could, for example, take away write permissions for everybody except for me. So this says for the group and for the other, take away the read and write permissions for that file. And now if I do ls-l, you can see that the only person who has access to that file is the user, that's me, Pechoric, and there's no other access for the other three groups of folks, other two groups of folks. Okay, so let me see. So that was basically what I have here in the in that section of the notes. Any questions about? I'll get back to where I was. Any questions about that? Yeah.
Is that as simple that you have file open?
That's a good question. I'm actually not sure off the top of my head, but because I think I have other files open. So yeah, I don't know what that is. Does anybody know?
Mac OS X has a richer set of groups than just user group and other. So
Okay, so that has something to do with another set of people. Yeah, I was curious. I don't actually know who those others are, what that means. But other questions?
If you copy a file, would you become the user of the file?
That's a good question. I often forget what the situation is there. I guess I'd have to do that on my. It would be easier to do that on the SCF. So let's see, where am I here? So let's see, if I go to /temp and I do ls-al, I can see if there are any files that are anybody else's. So I'm going to show you a little trick. This is basically going to pass the output of ls into a program called less. We'll see what this means in more detail in a little bit. But this is going to allow me to page through the results and not have it all spit out to the screen at once. Why are these all my files? Something's wrong here. So there should be, I would think there are other people using this machine. Let's see. Oh, I guess I didn't, oh right, I didn't go to /temp. Okay, that was the problem. So I was just trying to find a directory that other people have access to so we can see. Okay, so here are some other files, or at least directories. Let's try and find a file. All right, looks like somebody here has this file, sample.kt, fast.pl, which is, I guess, a Perl file. So if I copy that file to my home directory, so I'm going to use the twiddle to put it in my home directory. So I'm just going to do a copy. Now I'm going to do cd. By default, that's just going to go to my home directory, and now I can do ls-l of that sample.kt that I just copied over. So yeah, it looks like it changed it to be my file on copying. Which sort of makes sense, because if I put a file of his in my directory, and it was his, and the permissions weren't set up for me to read it, then I've copied over a file to my directory that I wouldn't be able to work with. Other questions? Yeah.
So when you do the chmod and make it an executable, suppose you want to do for all .files.
Yeah, so we're going to see that in a little bit. So let me hold off on answering that question. Okay, so let's go back to the where do I want to go here? Okay, so I gave some examples here. So the person was just asking about executable permissions, which I'll actually go into more detail in a minute. So I'm going to delay that. So there's a bunch of things for zipping and unzipping files, and in Unix has something called tar, which basically allows you to easily zip up a whole directory structure, and it's sort of analogous to zip, say on Windows. So I'm not going to go into all of the details of this, but there's some examples there and in the notes. A little bit about disk usage. You can see how much disk space is free with df and how much is used with dh. And the -h flag basically says make it human readable, so write it out in like megabytes and gigabytes and whatnot in a nice readable format.
so this basically says how much. Let me do this on the SCF machine actually. If I say disk free minus h here, it gives a whole bunch of. This is getting to be a little bit big. Gives a whole bunch of directories on the system. Some of them are from the file system, some are local to the machine, and it basically says how big is that part of the file system, how much is used and how much is available, and then these are basically the directories that it's looking at. So this gives you some idea of how much space is available. So if we, for example, were interested in how much space is available in the /temp directory where people might put some temporary files that they're using as they run through various jobs, it says, oh, you know, that /temp has 3.7 gigs available, of which only 175 megabytes are used, and so there's still 3.4 gigs still available for use. So you can get that sort of an idea for that sort of thing there. And if we do disk use minus h, it'll basically print out for all the various files below it in the directory tree. This is on my home directory, so there's a lot of stuff in here. Basically, what are the different files and how big they are, so you can get some idea of how much space is being used for all the various stuff. So I have a lot of stuff in my home directory, so maybe we should just quit out of that. So I hit Control-C to get out. But for example, you could see that within the directory from which I had materials when I taught this class 2 years ago, there was 830 megabytes of stuff. If I had some testing directory within that class directory, and that only had 11 kilobytes of stuff in it, et cetera, et cetera. If I'd let it go all the way down, it would have given a total summary at the bottom of what was in just that, what was in total in that overall directory. And if you want to know what your quota is on the SCF of how much space you have available, you can type quota, and that will give you an idea of how much, what your limits are and how much you've used. So I think this is, you'd have to interpret what this is. This should be like 35 gigabytes, so it looks like it's in kilobytes at the moment. Okay. I think I may have mentioned this before. Whenever you want to get help on a command, you can do man. So you could get information about the copy command, for example. It's going to give you all sorts of information about the different flags that can be passed. And if we want to know if a command exists on the system, this came up in one of the Piazza exchanges. We could say which R, for example, and it says, oh yeah, R is on the system. If the R executable is located in this particular path on the system. If we said, you know, something like, is there a command RR, it would say, nope, that thing is not found. There's nothing called RR. Or if we want to do MATLAB, MATLAB's on the system, RStudio is on the system, et cetera, et cetera. Remember, it's case sensitive, so if we do it like this, it would say you can't find RStudio capitalized in that manner. So let me, I want to show you a little bit about Emacs. There's a little bit more stuff in this, in the handout that you can look through on your own. I think I forget if I mentioned this before, but basically, for a lot of what we do in terms of computing, we want to have a text editor that allows us to edit just plain text files, and that gives us the capability to interact with text files that are in different formats. So if you have a good editor, it allows you to interact with files of code or files of LaTeX commands or other kinds of files in a way that makes it really easy to work on those kinds of files. So I have a list of some of the different editors that might be useful for different operating systems there in the PDF. But let's go ahead and open up. Let's see, how do I want to do this? So let me copy a file from copy a file over from my SCF home directory or to here. Okay, so that file doesn't exist. I think maybe that's the problem. Okay, so I just copied that over. So I have a file of some R code that's for doing a particular analysis that I'm in the middle of working on over the last year or so. So if I open that up in Emacs, so we're already seeing that Emacs is basically highlighting the comments in this file of shell script code. So this is basically a flat text file, but it has Unix commands in it. So it's already doing some highlighting in that file. If we open up the that R code file that I just showed you, that I just copied over, I mean, we can see it does some nice highlighting here as well. So it's highlighting some particular keywords like function, and requires the name of a particular function that's used for loading in packages. It's highlighting the comments. It's highlighting highlighting strings that are in quotes. So it gives you a lot, some nice formatting to allow you to basically be able to see what's going on in the file quite readily. And if I were to start typing stuff in, if I start creating a new function here, so my new fun gets function, you can see that it basically highlights stuff on the fly, and then if I say start to close a parenthesis, it does some nice things like showing where's the start of the parenthesis that I'm closing here. So it does a lot of nice stuff for us that makes it easy to do stuff. And it does automatic tab indenting or space indenting when I'm creating a file, so it's going to clean stuff up for you as you go along. So it's quite nice to be working with a nice editor like this. Another thing that you can do with Emacs is you can set it up to basically run R from within Emacs using something called Emacs Speak Statistics. So I'm not going to demonstrate that here, but that is something that quite a few folks use as a way to be able to basically have a file with their code in it and be just typing in a text editor with this sort of editing capability, but then be able to run the code in R really, really easily from within the file. So those are the sorts of things that you can do in a good text editor. The thing about Emacs, I have this table in the PDF that shows a bunch of the shortcut commands for doing things in Emacs. So if you get familiar with, there are lots more. There are hundreds and hundreds of these. But if you get familiar at least with the basic ones, you can do things just by hitting Control X or Control A or these various things, and you can sort of manipulate your file quite easily. So for example, if I wanted to, let's go back to Emacs here, I can do things like Control A will get me to the beginning of the line, Control E will get me to the end of the line, Control A, and then if I hit Control K, that'll kill off the entire line. If I hit Control Y, that'll copy it back. So I could, for example, remove that line and then paste it back down here. And what I did was I hit Control to cut it or kill it, and then I hit Control Y to paste it back. If I do Control Shift _, that'll undo the last things that I did. So I'm just continually rolling back the last few things that I did. And suppose that I'd made some changes and now I wanted to save this as a new file. I can hit Control X, Control W, and then that brings up a little prompt down here in this buffer, in this command window down here, that says, okay, you want to write the file as a new name, so now I can enter a new name for the file, and that basically creates a new copy of the file with a new name. So I could say, this is my new R file.r. So that's going to write it as a new file. So I'm not giving you, a lesson in how to use Emacs here. I just want to sort of expose you to some of the things that a good text editor can do. Different text editors will have different kinds of shortcuts for doing various things, but this is just one that a fair number of people use. Okay, so that's essentially most of what I wanted to say in this first unit, just trying to give you sort of a basic introduction to some of how we operate in a Unix environment. Are there any questions before I go on to the next unit? Yes. Better. So there are lots of people who use Vim and lots of people who use Emacs, and a fair number of people who fight about which are better. I'm not going to weigh in on which is which. I happen to use Emacs because I got used to using it, so I like Emacs, but I'm not going to say that it's better than Vim. It's just a different editor. Any other questions? Okay, so let's switch over to the next unit. All right, so again, I've got a PDF and I've got a file of shellcode here that is basically sort of the code that's been extracted from the PDF and that I'm using as a demo. So let's move over to this here. Okay. So this is going to be stuff where I'm really specifically talking about one particular shell for interacting with the Unix operating system. So basically, the shell is basically the interface between you and the operating system, and there are a variety of different kinds of shells that you can use, They all do basically the same sorts of things, but the syntax in terms of interacting with them is somewhat different. So this unit is basically about interacting with Unix using a shell called the bash shell, which is quite a common one, and is the default on a Mac, and is also the default on the SCF. There are others. There's an older shell called SH. There's a shell called the C shell and the TC shell. This TC shell is quite commonly used, but we're going to use bash, and we're going to be interacting with Unix through bash. So if you're on a system and you want to know what shell you're using, we can do something like this. So basically, we're getting a little ahead of ourselves here, but there's something called an environment variable, and often environment variables are all in caps, and if we want to query them or interact with them, we'll use a $sign in front of it. And so if I say echo this variable name, this is going to say what's inside that variable. So just like a variable in C or in R or anything else, it stores some information. So echo just prints it out to the screen and says, oh yeah, you're actually using the bash shell. If I had typed tcsh, that's going to switch me over to the tcsh shell. And now if I do, well, that's curious. That's not what I was expecting. So you can see that let me do that on the SCF and see what happens. Okay, so if I do that on the SCF, you can see it sort of changes what my prompt looks like, because then that's some indication that I've switched shells. If I do that same thing again here, I'm wondering if the fact that it was still saying bash is something going on with a Mac. Maybe shell is just related to bash. So yeah, I'm actually not now sure off the top of my head how I would query to see which shell I'm using, because I thought that was going to do it. Does anybody know off the top of their head? No? Okay. I'll try and dig that up after class and let you guys know about that. But I can hit exit, and that will get me back out, and this is now back in my bash shell, which is where I want to be for the remainder of the unit. But that was just an indication that you can change shells. Okay. So let's go ahead and first see that we can actually use a file. We can actually put commands in a file and execute them, a bunch of commands all at once from a file. So what I'm going to do is I'm basically going to create a little a new file here. I think I'm going to do a slightly different demo than what I have in there. So I'm going to create a file that does this. It says echo this prints out long format file info, and then I'm going to do ls-l. So I'm just writing some shell script code. First something that just will echo a string to the screen, and then I'm just going to do ls-l to print out the files. So if I now go Control-X, Control-W, I'm in Emacs, I'm going to save this as myls.sh. So sorry that this is so small. I'm not quite sure off the top of my head how to make this bigger. But what I'm doing is I just created this file, it's just a text file. I'm saving it as a file named myls.sh. So myls is just to remind me that this is my little ls shell script. And .sh is to indicate that it's a file that has shell script code in it. So I can do that. And I'm just going to exit out of this. And now if I say ls-l, oh, there's a lot of stuff in here. ls-l, my ls, what was it? Oh, right, I'm in the wrong place here. So let me get out of here. Okay, so I had opened a file and then edited that in Emacs on my local machine. So I need to be in a terminal window on my local machine. So if I do ls-l, we can see that it's indeed created this file myos.sh. A couple things to notice about it. There's not much in it. It's only 50 bytes, I guess. And we can see it has read and write permission for me and read permission for any people in my group or other users. So I want this thing to be executable because it contains commands, Unix commands, that I can in principle execute. So what I can do is I can do change mod user, let's say I'll make it executable by everybody, myls.sh. So this is going to change it so that it is actually executable. So does that address your question about changing permissions for executable?
But this is not like for every sh.sh.
Okay, right. So let me answer that in 1 second. So I'm going to change permissions for that file, so now you can see it's listed as being executable for everybody. If I wanted to do that for all of the .sh files in this directory, I can use something called a wildcard, which we'll see in more detail in a little bit. But I can do this, and what the star stands for is anything. This is gonna basically expand out to be any of these file names that end in .sh. So actually, the dot is also a wildcard, so I think that's maybe not quite accurate. So let me do it this way. So this is gonna say change to have executable permission for any file that ends in sh and starts with anything. That's what the star stands for. It starts with anything and any number of characters before sh. So now if I do ls-l, we can see that it added executable permission to all of the things that are the sh files here. So if I now want to execute the various commands that were in that myls.sh file, I can't quite do this. This will generally not work. But what I can do is this. So this tells Unix right here in this directory, execute this file. So if I do that, you can see what happened. It did execute it, and you can see at the top that it printed out that little string that I had included in my myls.sh file. It printed out that this prints out long format file information, and then it just went ahead and executed the ls-l. So this is obviously a pretty silly little shell script because it just does something that ls-l already does. I don't need the shell script to do that. But I could embed, as many lines of arbitrary shell code that I wanted to in that file and execute them all at once in this manner. Okay, questions or comments about that?
So do you have to write a /bin/bash in the first line?
Yeah, so it's a good idea. Actually, I should have said that, and I said that in the notes, but I forgot to do it here. If you want to make sure that Unix is going to execute, I thought Aquamax was already open. If I want to make sure that it's going to execute using the bash shell instead of some other shell, what you would then generally put in is this. And this is basically a flag to the operating system that says, sorry about that. The first line is a flag to the operating system that says execute this code using the bash shell. So that's in general what you would want to do. Okay. A couple things about navigating around. I forget if I mentioned this last time, but Unix has tab completion. So I guess I think I did say this, that you can basically start entering something and hit tab. There's no MATLAB on that machine, but there should be MATLAB on this machine. And if I hit a tab here, it just basically completed the command MATLAB because it knew that the only thing that starts with MATL is MATLAB. So that can save me some typing. Or if I said copy, let me do that over here. Oops. Here I am back on my laptop. If I say copy and then I start to type out nicer.sh, which is one of the files there. If I now hit a tab, it's going to complete the whole name of the file because that's the only thing that starts with ni in this directory. So it knows that that's the obvious thing to complete it with. So you can basically hit tab to try and complete anything instead of having to type it all out, which is really nice with long file names or long commands. The other thing that you can do is you can hit up arrow and down arrow to basically scroll through the various things I've executed in the past. So I'm just scrolling back up through all the various things I've executed during class today. And if I hit down arrow, I'm going to scroll back down. So you can think that there's a whole list of commands that I've executed, and I can use the up arrow and down arrow to go up and down and basically recall any commands. So suppose I had typed in this whole long scp command, and I realized, actually, I think I did this on the fly without pointing it out to you. Originally, I had done that. Or originally, I think I did that. And I said, oh, that's not right. It can't find that file. So then I hit up arrow. Oops. And then I just used the right and left arrows to go back and fix the character that was incorrect. So that's quite powerful. And another thing you can do is you can, if you do, I'm just doing Control A, Control K to get rid of that. If I hit bang or exclamation point, I can basically, if I do this, it's gonna execute the last command that I entered that started with SCP. So that was presumably when I copied over that file, and what you can see is the last one I did was this one where it failed to do the copying because the file name was wrong. So this says redo that last command. It tried to go ahead and redo it. It still fails because it still has the error in it. But I can basically re-execute commands using that exclamation point and then the first few characters of what I want to execute. So there are a lot of shortcuts like that. So any questions about that? Yeah.
Can you have several files at once, for example, all the files start with a unit?
So if I wanted to copy, yeah, so actually that is a nice lead into what I was just going to say about wildcards. So suppose I wanted to take all of the shell script files in this directory and copy them to /temp, because for some reason I wanted them there to be able to work with them, or I wanted to sort of do a quick backup of some files to somewhere else on the file system. So I can do that. So what this says is copy from this directory anything that ends in sh to /temp and just sort of use the same file name as the original file names. So that's what that will do. And now if I do ls/temp, we can see that it indeed has copied over these various files that ended in sh from that lectures directory. So that's a nice example of using what's called wildcards, which we've now seen a couple times here on the fly. Other questions? Yeah. No, we talked about that last time in class, and there's a little bit of discussion on the Piazza site over the weekend. But you can't really undo things directly. There are some nice tips on the Piazza site about some tricks for like having a trash folder and stuff like that. So you might want to look at that. Is there another question? Yeah.
Is there a similar command like the tab completion for the command use typing?
Yeah, tab completion will work either for commands or programs or for files, depending on where you are, sort of in terms of how much you've typed out. So when you first start typing something that's expecting a command, so it'll try and do tab completion of command. If you're then typing in something after command, it might be expecting a file, and then it will tab complete the file name.
And I'm talking about the this SAP command use to type in like copy some file. So it's not like a built-in command. It's some command. The whole command is SAP copy file.
Well, SCP is a built-in command, then I have to give it the file names that I want to
Yeah,
copy.
it's asking like, can I like do tab completion to complete the whole command?
Well, no, you can only complete the individual pieces, either an individual file name or an individual command, because otherwise Unix has no way of knowing that you want to complete that whole thing, because that's made up of discrete pieces that make up the command.
Okay, so in terms of wildcards, I want to say a little bit more about these wildcards. Sort of losing track of where I am here. So let me get back to where I was. So let's make sure I'm in a place where I can go ahead and that these commands will make sense. So I guess I'm already there. Okay. Okay, so I can do things like this. So we've already seen the asterisk for wildcards. This says anything that ends in either PDF or SH. That's what the braces and the comma means. So you can see it printed out it printed the names of all the files that ended that were either PDF or shell script files. I can do some nice things like if I wanted to make a backup of that nice r.sh file, I can do things like this. So what this does is the shell is going to expand this to be, this says either nothing or .backup. So what this is going to do is it's basically, if I put an echo in front of this, it'll show what the shell will expand this out to in terms of interpreting these various wildcard type syntax. So what it's doing is what this part becomes is copy nice r.sh to nice r.sh.backup, because there's nothing in front of the comma and there's the .backup after it. So if I actually just wanted to execute that, I would obviously take away the echo part And this will then just make a nice backup for me without having to type in the nice R twice. So you can see there's now that .backup file there. And you can use wildcards basically with any commands. I could remove any file that begins with nice R. So I'm not worried about doing this because even though I want niceR.sh, I know it's in my Git repository, so I can just get it back anytime I want it. So I'm just going to go ahead and remove it. And now if we type ls, we can see that all of the files that began with niceR are no longer there. Let's see, questions, comments? Okay, so there's some more syntax in the slides that gives some more of the syntax for these various kinds of wildcards. And it can get fairly complicated as well, but I'm just sort of showing you some of the basics here. Okay, so let's switch over to the slides briefly. I want to show you a variety of different utilities that are available in Unix. So the basic thing that we've already started to see is the basic structure of a Unix command is the name of the command, and then there are various flags or options that we are usually set off with a minus, and then there's often a single letter that indicates the particular option that you're trying to use. So we've already seen that with ls minus l. You can do ls minus a, ls minus t. These are various flags that are possible. And then basically you have various numbers of arguments that you might put in. So as another example of this, we haven't seen this command yet, but there's something called grep that will look for a particular sequence of characters within a file. So for example, grep graphics file.txt will look for any lines in file.txt that contain the character string graphics. So we'll basically pull out and print out those lines to the screen. If I do the -I, it says ignore case, and that might print out graphics capitalized, or graphics just with a capital G, or graphics all in lowercase. So this is an option or a flag that we can pass into the grep command. And lots of these Unix commands have lots and lots of these different flags, and you can see what those flags are with the man command to get help on it. Oftentimes it's sort of overwhelming because there are like hundreds of different options, and you're only interested in the five common ones that people tend to use. But that's just sort of how things are. Sometimes you have flags that are with a -. So you might see flags that are things like just plain -l. But I think if you're going to have a flag whose name of the flag is more than one character, it needs to have a --. So for example, we might start R with ---- no save. I won't go into what this means, but this is the no save flag that you're toggling on, and the ---- is basically saying that's the flag, but it happens to be a longer name than just one character, so it has a minus in front of it. Okay, so what are some of these utilities these are some of the utilities that are really useful when we're working with files and manipulating files in Unix. So there's a command called tail that will just show the last few lines of the file. There's also a command called head that will just show the first few lines. We already saw less. That will basically page through a file when we have a very long file and we don't want to just print it all out to the screen at once. Cat will do something similar, that I'll just write a file out to the screen. Something called WC that basically counts the number of lines and words in a file. That can be quite useful. Grep we just saw if we want to find patterns in a file. There's stuff for downloading files from the web. This will be a big part of one of the problems on the first problem set. We can sort file. We can number the lines in a file. We can compare two files. When they're text files, we can compare them to see what lines differ between one file and another. We can remove rows that are repeated, and we can also cut. What cut does is it basically extracts columns from a file where we can tell it what the delimiter is that divides the columns. So if we had a file that was divided by commas, we could say, give me back the fourth and the fifth columns where the columns are specified by commas, for example. So those are sort of the main ones that I find useful. So let's actually do a little bit of a demonstration of this. So I'll just do a little bit with grep. So for example, I'm going to so I just did grep ls*sh. So what does this do? It says in any file that ends in sh, whose file name ends in sh, look for the character string ls in those files. So what does it do? It goes through and looks for ls. Let me actually put that in color. This will show another, I think minus C or minus, let's see, is that going to work? No. Color. There we go. So this is an example of one of these flags where I have the double minus. So this is basically showing me in each of these files which of the lines in those files have ls in them. So in this unit2-bash-bash.sh, this line appears in the file, so does this line here, so does this line here. So I can basically see wherever ls came up in my in these various shell script files if I was interested in seeing how I had used it in the past in these files. If I wanted to only get the if I only wanted to find the lines where it starts with ls and not just where it's anywhere in the file, I can put a caret in front of it, and that only shows me the lines where the first two characters in the line are actually ls. So you can see this is a subset of those lines up there. There's tons of syntax that goes along with grep in terms of specifying different patterns, and I'm not going to go into a lot of the details here. There are a few basic ones are in the slides. We're going to work a lot with pattern matching and pattern recognition and replacement of patterns using something called regular expressions, but we're going to do it from R rather than doing a lot of it from the command line. So you're going to see a lot of this kind of syntax of trying to find patterns, but we're going to wait to do that for a couple weeks. Let's see. Just to give you another example of this. So here's an example of the use of tail with a particular flag. So I'm going to open up a new shell window and just start R in that window and just start some code running. Oops. So I've started R, oops, and I'm just going to start a long for loop so that it keeps running and printing stuff out to the screen. This is just for the sake of demonstration to see how we can use this command tail. Okay, so that's printing a bunch of stuff out to this file called clt.txt. Actually, I'm going to actually make that longer so that it keeps running for a while. Okay, so now if in here I do tail minus f clt.txt, it'll basically update on the fly and just show me as the file is being written to what's being written to it. So that was an example of tail will generally write out the last few lines of a file, and the minus f flag to tail says just keep updating and show me all of the lines as they get written out. So if you're trying to see sort of what's going on and what's being written to a file on the fly, that can be pretty useful. So all I did there was just tail minus f and then the name of the file that was in the process of being written to. So the only purpose of the R code here was just to write stuff out to a file so that it was being written out as I was doing the demo. So those are just a few of the helpful commands or utilities that are available in Unix. Yes. I'm not sure if cat would, or if it would just show the snapshot of what was in the file right at the moment you typed cat, and then it wouldn't show the remaining. I think it probably would not show it all scrolling out in the way that tail minus f did. So let me say one thing about what's called redirection, and then we'll really launch into that on Friday. So I can basically redirect the output of any command into a file. So if I do this, what I did was I did that same thing with grep. We're finding all the lines in the sh files that have an ls in them, but now I'm redirecting the output so it doesn't go to the screen. Instead, it goes to a new file. So that's a really useful thing if I want to save the results, and then maybe later on I want to process the results from this file somewhere else. So I basically can read and write from files using this redirection. And you basically use an open arrow to redirect output into a file, and you use a less than arrow to read stuff in from a file. Yeah, question?
Is that ls stuff already created, or
So right now this is being created, and if I did it again, it would just overwrite it. But if I did it with two greater thans, it will then append to the bottom. So if I now look at my stuff or my ls stuff, it should show 2 copies because I've written into it twice. If you looked at it carefully, you'd see that it showed up twice. Okay, so let's stop there for today. When we come back on Friday, I'll go into a lot more of taking these commands and basically chaining them together to do really powerful things with these individual commands. Hey. Just a second. I have to run to a call, but I can chat for 30 seconds.
Just a quick question. I'm a first year PhD student in the economics department.
You mean what?
In the economics department. And I tried to register for the course, and I couldn't even get to the waiting list. So maybe
When did you try?
Before a week ago.
Oh yeah. Try again because they're now the wait list is now just down to 12 people, so it should be available to get on.
Okay. And I'll try to chat with you another minute and Friday.
Okay, that sounds good. I'll be around. Yes.
So I think we just want to stay on the class.
Yep, that's fine.
Still go through the process of doing SCF stuff.
In terms of the SCF accounts, if you're just sitting in, probably not. I mean, if you wanted to be able to try out stuff on SCF as opposed to on your laptop, you could get an account, but you should be able to do most things.
And is there a way? I mean, I think last I checked, I was still on the wait list to get in. I think I'm gonna do a little drop.
Okay.
Is there a way to stay enrolled on the class and stuff?
Yeah, I mean, I think as long as you're on bSpace and Piazza, presumably, I don't think you're going to get automatically kicked off, so you can just stay on and still have access to materials.
All right, that's good. Thanks.
I'm not sure who is next.
It's actually pretty.
Actually, let me do one thing before I forget, and then I'll get back to you.